Hello, today's lesson is proportionality in graphs, and this is lesson 9. Our goal is I can discern whether a graph is proportional or non-proportional. We're going to try to relate this proportionality and non-proportionality now to graphs, just like we did with tables. This is a long lesson. We're going to break it into two parts. We're going to skip over this first part and we're going to go directly to the bottom part of page 31, and we're going to talk about what the characteristics are of proportional and non-proportional graphs. Several times during this video, I'm going to ask you to pause and just write down information in order to save time after we've discussed how we've gotten the information. So let's get started. Before we identify the characteristics of proportional and non-proportional graphs, I want you to notice, what you may have already, that this graph looks different than these graphs. And these graphs show what's called the full coordinate plane. So a coordinate plane is divided into 4 sections. So if I take my x-axis and my y-axis, what happens is the graph is divided into 4 equal sections, and we call these sections quadrants. So quadrant means 4. So this is quadrant 1. I'm going to abbreviate. This is quadrant 2, quadrant 3, and quadrant 4. And we use Roman numerals for those. That should be a 3. And we frequently tend to work in just quadrant 1, which is what you're seeing here. It's quadrant 1, and that's because all of the y values and the x values are positive. So if I go over here to quadrant 2, then my x values are negative x values, and my y values stay positive. And so each quadrant has a different set of ordered pairs. So we're going to stick to quadrant 1 when we do our graph, but right now let's go on to the characteristics. So it says compare the two graphs below, jot down your observations in the table. We're going to go just directly here, but we will talk about some of the observations. We're going to discuss these two proportional graphs. And what I want you to know is they're both straight lines. So a proportional graph must have a straight line. It must be a straight continuous line. And this is very important, and this might be new to you, it must pass through what's called the origin. The origin on a coordinate plane is a point 0, 0. So it's where the two x and y axes come together, and that 0, 0. Even if we just had quadrant 1, this starting point would be 0, 0, also known as the origin. So the straight line must pass through the origin. And so if just to be clear, that's point 0, 0. So if you need to pause and write that down, please do. Next, we're going to look at non-proportional graphs. And this was kind of confusing because I see a straight line, and it said a proportional graph's a straight line. However, a non-proportional graph can be a straight line, but it cannot pass through the origin. So we're going to write that down, okay? It could be a straight line, and we would put that does not pass through the origin. At any point, you can pause to copy this down. Then, you're also going to notice that this is a curved line. So I want to draw another situation that they didn't show, but I'm mentioning a line. So this is a line, and then this is a line, and this is a line. However, you're going to notice that it's not a straight continuous line. It's made of line segments. So it can a proportional graph could have some kind of curve in it, and it could be made up of line segments, but it also could be a straight line, but it cannot pass through the origin. And even if this curved line passed through the origin, it would not be proportional, non-proportional. So now let's try to build a table, a graph together. So please turn to page 32. All right, so this is our reminder that proportional relationships are straight lines and pass through the origin. So that's what we're looking for a proportional relationship. So if we look, we have a lot of blank things in here, and they just give us one little piece of information. And from this one little piece of information, we can build all of this. So concert tickets go on sale for $34 each. So if I hear the word each, I know that that is one. So it said that it was $34 for a ticket. So X would be my tickets, and they told me one ticket, and Y would be the cost. When they say revenue, that means how much a venue someplace would bring in, like a concert hall. So that would be $34. So now that's all they've given me. And from this, I already know the unit rate, otherwise known as the K value, because they said 34 for one. So this is already a proportional table. $34 for one ticket. That's all the information they gave us. So now I can just make up the amount of tickets. And for this reason, X is often referred to as the independent variable, because I'm allowed to just make it up. It doesn't depend on anything else. I shouldn't say I'm allowed to make it up, but it's not dependent on something else. However, Y is dependent, meaning it depends on how many tickets I buy. So whatever I write here, this number depends on this. Whatever I wrote here, whatever my answer here depends on this. So if we know also the K value, guess what else we know? We also know the equation. We know that this is Y equals 34x. That's the K value. But we're going to use it in our table like this. We're going to take 34 times our X values, and then we're going to know our Y values. So I'm going to start by showing you if I took 34 times 1, it would give me back 34. So if I take 34 times 2, that's going to give me back 68. So one more time, if I took 34 times 3, I'm going to get 102. So for the sake of time, I'm just going to quickly jot down all these numbers. If you need to pause the video to copy them down, you're welcome to do so. So that would be a continuation of taking all of those X values times 34. Now next, an ordered pair. I'm assuming that you've probably talked about an ordered pair before, but ordered pairs are the X value first with the Y value. They must be enclosed in parentheses because an ordered pair makes 1 point working together, coordinating together. They make 1 point on a graph. So we get these ordered pairs right from the table. So this would be 134. My X value is 2 and 68. And so I just take my X value with its coordinating or matching Y value. So again, I'm just going to write these down quickly. You can pause at any moment that you need to catch up. All right, so now we have the table, proportional table. We have the ordered pairs that we can make the graph with. So now we have to label the x-axis. And if you can't see this is x, and we get that from the table. They're telling us this is the amount of tickets sold. So I'm going to label that as tickets sold. So that would be the number of tickets sold. Then you're going to notice here they talk about the Y values. So that would be the money, the total revenue. So I'm going to write that as total revenue. And revenue means money coming in. All right. So again, they haven't given us any numbers, so I'm just going to frankly use the numbers from my x-axis. So if you'll recall, this very beginning line is 0. Then I'm going to count this as 1, 2, 3, 4, 5, 6, 7, whoops, 6, 7, and I'm going to stop. I can continue with 8 and 9, but at that point I'm going to stop. Now, the y-axis is a little bit trickier. If I tried to go from 1, 2, 3, 4, I'd never make it up to 34. So I'm allowed to create what's called a different scale as long as I'm consistent. So I'm going to put 34, and as long as I'm going up by 34s each time, that's okay. So I'm going to use the numbers that are given. So I'm going to count this as 34, 68. This right here is 102. And again, you can pause the video and take your time to fill this in if I'm going a little bit fast. And this would be 272. If we continued our calculation, 306. All right, so we are now going to graph these points. And I have 1 and 34. Now, when you graph, you always go right or possibly left if it's negative, and then move up or possibly down if it's negative. We have all positive numbers, so I'm going to start right here at the origin, and I'm going to go over right 1 and then up to 34, and I'm going to make a point right there. Then I'm going to go to my second ordered pair, and I see 2, 68. So I start at the origin, and I go over 2 to the right and up to 68 and make another point. Again, I'm going to start back with my third ordered pair. I start at the origin and go right 3 and up to 102. And so I'd like you to continue. You can probably see a pattern happening. And at this point, many of you might have noticed from the beginning I made, making this graph, I made a mistake here. I corrected my scale. So right here, I apparently liked 3 so much, I made 2 of them. So now that we have this, we have all the points that are on our ordered pair. I want you to notice if we tried to connect them, we would have this line. We would start from here and here. So I see a straight line. However, I don't have the ordered pair 0, 0, but if I continued that pattern, it would indeed touch the origin as well as extend out this way. And that 0, 0 is a very important point. It also tells me that on the graph, even if I don't see it, if I can extend my line and include 0 and 0, which I'm now going to add to my graph, I'm going to write 0 here and 0, that is very much a proportional graph. And this would make sense for a table too, because if I bought 0 tickets, I would pay $0. So that makes sense for the graph too. So here's where we're going to stop for today. I'd like you to make sure you have all these notes, because tomorrow we're going to answer the questions at the bottom regarding this graph. Thanks for listening. Bye-bye.